Let's consider first a simple function r of t equals a cosine pi t I plus sine pi t j. We're going to calculate the curvature and the arc length on the interval from 0 to t, on the interval from t equals 0 to t equals 1. Now our definition of curvature is the rate of change of the unit tangent vector with respect to s. And to calculate that, we calculate first derivative of the unit tangent vector with respect to t divided by magnitude of ds dt. Didn't really need magnitude on this, but that's going to be dt d of big T with respect to little t divided by the magnitude of dr dt. Now, what's our unit tangent vector? First of all, r prime of t equals a times negative pi sine of pi t I plus cosine of pi t times j. So our unit tangent vector equals what? A times this, negative pi sine of pi t I plus cosine of pi t j divided by the magnitude of this vector, which is going to be the square root of the sum of the squares of the I and j components. That's going to be negative pi a sine of pi t quantity squared plus a distributes, and it looks like I lost my pi here. Okay, and then we're going to have pi a cosine of pi t quantity squared we're going to be able to factor out a pi squared a squared from this term, and then a pi a from the square root, leaving us sine squared of pi t plus cosine squared of pi t, and that's going to be 1. So that our denominator just becomes pi a, and when we divide pi a into what we have here, we're just going to end up with negative sine of pi t I plus cosine of pi t j. And I'm not going to write out all the details of that division. So the derivative with respect to t of our unit tangent vector is just the derivative of this, which is going to be negative pi times the cosine of pi t I minus pi times the sine of pi t j. The magnitude of this derivative is just pi, and that should be fairly straightforward. Just write out the sum of the squares of these. We're going to have a cosine squared, a sine squared. We're going to be able to factor out a pi squared, factor that out of the square root, just like what we did up here, except we don't have the a term anymore. And then our r prime is just this. We're going to need to divide this by the magnitude of this. So let's note here that the magnitude of r prime of t is what? Well, that's just going to be the square root of this squared plus this squared. We're going to have a pi a in each of the factors. We're going to have pi squared a squared, And then we're going to have a sine squared of pi t plus cosine squared of pi t. And that's going to equal pi a. So that when we finally calculate our curvature, we get curvature equals magnitude of dt ds, which is magnitude of dt with respect to the small t, divided by the magnitude of dr dt, and that's going to come out to a fairly simple expression. This derivative, the derivative of big T with respect to little t, is just pi. Dr dt is just pi a, and that's 1 over a. So it's a lot of work to come out with a simple expression, but this is our curvature. How do we interpret that? Well, what is this function? What is the graph of this function? It should be clear that the graph of this function is a circle of radius a. So that what we have here is reciprocal of the radius. So in this case, where we have a circle, we have a constant curvature 1 over a, which is equal to 1 over the radius.